Welcome to the Chapter 7 quiz number 1 answer key explanation video. So as we go through the answer key, you'll see on the first 2 pages here, the ones that are basically the review that was handed out to you, majority of all I put on those pages were the solutions or the graphs. For the work piece, if you go down to the next 2 pages, so the last 2 pages of this 4 pages, you will see the work for the majority of the review. So first off, if we look up here, for numbers 1, 2, and 3, they want us to solve each system by graphing. So what you want to keep in mind is that the easiest way to do the graphing would be to write each one of the equations in y equals mx plus b form or slope-intercept form. That way we can then do the graphing more easily. So for example, in number 1, neither of these equations are written in y equals mx plus b. So here is the work for changing them to y equals mx plus b. So for the first equation here, we have 4y plus 5x equals a negative 4. So to get y alone, we first need to subtract 5x from each side and then divide everything by 4. So we end up with y equals a negative 5 over 4x. And you want to leave that as a fraction to make your slope easier, minus 1. So we know our y-intercept's negative 1, and the slope is a negative 5 over 4. With our other equation, 12 minus 4y equals x, we need to subtract the 12 from each side, and then divide everything by the negative 4 to get y alone. So we end up with y equals a negative 1/4 x plus 3. So our y-intercept is a positive 3. Our slope is a negative 1/4. So then when we go back up to the graph, now that they're in slope-intercept form, I could graph them. So the one equation, y equals negative 5/4 x minus 1, is right here. We're starting the graph at a negative 1 for the y-intercept, so over 0 down 1. And if our slope is a negative 5/4, that means we'd go down 5, right 4. But that's going to go off the graph, so we could go in reverse to figure out our second point. Up 5, left 4. And there's that point to draw the first line. For the second equation, we had y equals a negative 1/4 x plus 3. So we're going to start at a positive 3 for the y-intercept, and our slope is down 1, right 4. Or in reverse, you could go up 1, left 4. So then when you draw the second line, you can see the 2 lines intersect at the point negative 4, comma 4. And that would be our solution to that system. So with number 2, we want to do the same. Take our 2 equations right away and write them in y equals mx plus b form. So again, going down to the work, with our first equation, negative 6y equals negative 24 plus 9x, we could rewrite that as a negative 6y equals 9x minus 24, just switching the order on the right, and then dividing everything by a negative 6 to give us y equals a negative 3 over 2, because 9 over 6 simplifies to 3/2, plus 4. So we have that first equation, y equals mx plus b. The other one, 0 equals 2y minus 4 plus x. We can subtract the 2y from each side. So we have negative 2y equals negative 4 plus x. We could rewrite that right-hand side, so x is first. So that'd be a negative 2y equals x minus 4. Divide everything by the negative 2, and y would equal a negative 1/2 x plus 2. So then when we go to graph those, our first equation, y equals negative 3/2 x plus 4, we're going to start at the y-intercept, positive 4, and follow our slope down 3, right 2. Down 3, right 2. And draw in that line. For our other equation, y equals a negative 1/2 x plus 2, we start at the positive 2, and our slope is a negative 1/2, so down 1, right 2. Down 1, right 2. Draw the lines, and we can see they intersect over 2, up 1, so our coordinates would be 2, 1. And then with number 3, again, we need to rewrite them into y equals mx plus b. So with the first equation, 16 plus 4y equals negative x, we'd subtract 16 from each side and then divide everything by 4. So y would equal a negative 1/4 x minus 4. With our other equation, 16 plus 7x equals 4y, y is already on its own, minus the fact that it's connected to 4, so we just simply divide everything by 4, and that would be 4 plus 7/4 x equals y, and when we rewrite that, we just flip the order, so y is on the left, so it'd be y equals 7/4 x plus 4. So graphing our two lines, with the blue line here, our y-intercept was a negative 4, and our slope is a negative 1/4, so down 1, right 4. With the orange line here, our y-intercept was a positive 4, so we're going to start at the positive 4, and the slope on that one was 7/4. So that would typically mean up 7, right 4, but we're going to run out of room. So instead, we would go down 7, left 4 to get our other point, giving us that positive slope of 7/4. And then we can see for that one, which I forgot to write my final answer in here, but the 2 points cross at negative 4, negative 3. So that answer would be a negative 4, comma, negative 3. And that would be the solution to that system. So what you want to make sure you do on all those is to put them into slope-intercept form first. Now moving down. With 4, 5, and 6, they want us to use elimination. So again, you'll see I have the answers here, but the work is down below. So let's go look at those examples with number 4. We have a negative 2x minus y equals 6, positive 10x plus 6y equals negative 22. I want to multiply the top equation by 5 so I can cancel out my x's. So that would give me a negative 10x on top minus 5y equals 30. Bottom equation is still 10x plus 6y equals negative 22. So when we add those, the negative 10x and positive 10x cancel. Negative 5y and 6y is just 1y. 30 plus negative 22 is 8. So y equals 8. Now that we know what y equals, we substitute that back into our original equation. So I put it back into 10x plus 6y equals negative 22. So 10x plus 6 times 8 is a negative 22, meaning 10x plus 48 is a negative 22. Subtract 48 from each side. 10x equals negative 70. Divide by 10, and x equals negative 7. So our answer would be a negative 7, comma 8. With 5, our top equation, x plus 4y equals negative 21, bottom 8x minus 4y equals negative 8. So I could simply multiply the top equation by 2 to allow my y's to cancel. So on top, I'd have 2x plus 8y equals negative 42, and on bottom, 8x minus 8y equals negative 88. So the positive 8y and negative 8y cancel when we add these. 2x plus 8x is 10x. Negative 42 minus 8 is a negative 50. Divide both sides by 10, and x equals negative 5. Now that we know what x is, substitute that back into one of the original equations. So I put it into the bottom one here. So it would become 8 times negative 5 minus 8y equals negative 8. So negative 40 minus 8y equals negative 8. To start to solve for y, we'd add 40 to each side. Negative 8y equals negative 32. Divide both sides by the negative 8. And y equals a positive 4. So our solution there would be negative 5, 4. And then moving down to 6. Negative 2x plus 5y equals 3, and 7x minus 10y equals negative 18. I noticed if I multiply the top by a positive 2, that will give me 10y, so I can cancel out my y's. So the top equation, when everything's multiplied by 2, becomes negative 4x plus 10y equals 6. Bottom equation is still 7x minus 10y equals negative 18. So when we add those, the y's cancel. Negative 4x and 7x is 3x. 6 minus 18 is negative 12. So 3x equals negative 12, divide by 3, and x equals negative 4. Now that I know x is negative 4, I can plug that back in. So I put it into the 7x minus 10y equals negative 18. 7 times negative 4 minus 10y equals negative 18. So negative 28 minus 10y equals negative 18. Add the 28 to each side. Negative 10y equals positive 10. Divide by the negative 10 that's attached to y. And y equals a negative 1. So our answer for 6 would be negative 4, negative 1. Now with 7, 8, and 9, as we look back at our directions for 7, 8, and 9, they want us to solve each system by substitution. So again, I put the answers up here, but the work is down below. I started with 7 just to show the first process, but then moved it down below to get more space. So if we come down here and look at 7, we have negative x plus 7y equals 3, and then a negative 2x plus y equals negative 7. So if I look at those two equations, the bottom one, it's real easy to solve for y by adding 2x to each side. So we end up with y equals 2x minus 7. So I'm going to substitute the 2x minus 7 into the original equation up top for y. So that would become a negative x plus 7, and then in parentheses, instead of the y, it'd be 2x minus 7. And that whole thing equals 3. So we need to distribute the 7. So we end up with the opposite of x plus 14x minus 49 equals 3. Negative x plus 14x would be 13x. So 13x minus 49 equals 3. Add our 49 to each side. Divide by 13, and x equals 4. Now I can take that x equals 4 and put it back in to figure out what y is. Well, if y equals 2x minus 7, it's 2 times 4 minus 7, so 8 minus 7 gives us y equals 1. So our answer to number 7 would be 4, 1. With 8, they already told us what y equals. Y equals 4. So half of our work is done for us. So we can just take that info, y equals 4, and put the 4 in for y in the other equation. So it'd be 8x minus 7 times 4 equals 12. 8x minus 28 equals 12. So add the 28 to each side. 8x equals 40. Divide it by 8, and x equals 5. So our answer there would be 5, 4. Remember x before y. And then with number 9, we have a negative 2x plus 7y equals negative 9, and x minus y equals negative 3. So I notice in the bottom equation, I can add y to each side to solve for x. So x would equal y minus 3, or a negative 3 plus y. It's still going to work out the same way. So the y minus 3 goes into the original equation on top here for x. So it becomes negative 2, then in parentheses, y minus 3 instead of x, plus the 7y equals negative 9. Distribute the negative 2, negative 2y plus 6, plus 7y equals negative 9. Combine the y's, negative 2y and 7y is 5y. So 5y plus 6 equals negative 9. Subtract 6 from each side. 5y equals negative 15. Divide by the 5, and y equals a negative 3. Now we can take that negative 3, and I'm going to put it back in here for y. So x would equal y minus 3, or negative 3 minus 3 more, meaning x equals a negative 6. So our answer there would be negative 6, comma, negative 3. And then we get into our last two problems, which are the different word scenarios. As I put out the message in Google Classroom, number 11 is harder than the ones that'll be on the quiz, so we're mainly just going to focus on figuring out number 10. So the key to number 10 is to take our, obviously, sentences and put them into math. So what we know in this case is Amanda and Scott are selling flower bulbs for a school fundraiser. Customers can buy bags of windflower bulbs and bags of daffodil bulbs. So right away, I know then Amanda sold 6 bags of windflower bulbs and 10 bags of daffodil for $212. Scott sold 13 bags of windflower bulbs and 9 bags of daffodil bulbs for $244. What's the cost for each 1 bag of windflower bulbs and 1 bag of daffodil bulbs? So to start, you want to just choose a variable for each letter. Windflower bulbs, I made X. Daffodil bulbs were Y. Now what I know is Amanda bought 6 windflower bulbs bags plus 10 daffodil bulb bags and spent $212. So 6x plus 10y equals 212. Then our other person, whose name escapes me, Scott sold 13 windflower bulb bags and 9 daffodil bags for $244. So 13x plus 9y equals 244. Those are our two original equations. Then I decided to use elimination or combinations to solve. So I wanted to cancel out the y's. So I'm multiplying my top equation by negative 9, bottom by 10. Those equations become negative 54x minus 90y equals a negative 1,908, and 130x plus 90y equals 2,440. When I add those, the y's cancel, so I'd have 76x equals 532. Divide both sides by the 76, and x equals 7, meaning the bag of windflower bulbs were $7 each. Then to figure out daffodil, I can take this x equals 7 and substitute it in for either of the original equations. So I put it into the top. So 6x, 6 times 7 is 42. So we end up with 42 plus 10y equals 212. Subtract the 42, 10y equals 170, divide by 10, and then y equals 17. So that tells me the number or the price for each bag of daffodil bulbs was $17. So our final answer to the question would be the bag of windflower bulbs were $7, bag of daffodil bulbs were $17. Now, for those of you that did attempt number 11, what you'll notice here is it requires a little work before we can do our two equations. The equations are actually quite simple with the plane speed plus the wind, or the plane speed minus the wind. So what we know in this scenario is the trip to LA and back each way was 2,240 miles. So one of the trips took 14 hours, the other took 20. So 2,240 miles divided by 20 hours tells me the average speed of the trip back was 112 miles per hour. Our trip there only took 14 hours, so 2,240 miles divided by 14 hours told me my average speed on the trip there was 160 miles per hour. They want us to find the speed of the plane when there is no wind in the air, so in still air, and the speed of the wind. So what I know is they told us the trip there was with the wind. So my equation would be plane speed plus the wind speed, because it's in our favor, equals that 160 miles per hour. For the trip home or the trip back, it'd be the plane speed minus the wind speed, because the wind was against them, equals the 112. In this case, it's already set up so I could use a combination because my W's would cancel. So I'd end up with 2p equals 272, divide by 2, and the plane speed in still air is 136 miles per hour. So we know p, the plane speed. Then I can substitute that into either of the originals to figure out the wind speed, or W. So 136 minus W equals 112. So subtract the 136, and we end up with a negative W equals negative 24. So we divide both sides by the -1, and we find out our wind speed was 24 miles per hour. So the plane in still air was 136 miles per hour. The wind speed was 24 miles per hour. But as I said, the problems that are on the actual quiz are going to be much more similar to problem 10 here.